Physics, Grade 10, Monthly Review, Semester 3. First, force and interaction. Resultant of two forces, F1 and F2. First, F1 and F2 have the same sense and same line of action. Then F equal F1 plus F2. So, as a magnitude, F equal F1 plus 2. F1 is equal to 3 Newton. F2 equal 1 Newton. So, 3 plus 1 is equal to 4 Newton. Now, F1 and F2 have the same line of action and opposite sense. Then F equal F1 minus F2. F1 is 3 minus 1. It's equal to 2 Newton. If the two forces are concurrent, if alpha equal 90, then F square equal F1 square plus F2 square. So F equal radical F1 square plus F2 square. If alpha does not equal 90, then F square equal F1 square plus 2 F2 square plus 2 F1 F2 cosine alpha. Example, find the resultant forces F. F1 equal 8 Newton, F2 equals 6 Newton. F1, the angle between F1 and F2 is 90, so F equal radical F1 square plus F2 square equal radical F1 8 square plus 6 square equal radical 64 plus 36 equal radical 100 equal 10 Newton. F1 equal to Newton, F2 4 Newton, and alpha is 60. So F square equal F1 square plus F2 square plus 2 F1 F2 cosine alpha equal F1 is 2 square, F2 4 square plus 2 times F1 2, F2 4 cosine 60 equal 4 plus 16 plus 2 times 2 4, 4 times 4 16 cosine 60 1 over 2 equal 4 plus 16 plus 8 equal 16 plus 4 20 plus 8 28. Then F equal radical 28 Newton. Now Newton's law. Projection of a force. If F is along x-axis, then the projection of F is F. If F in opposite direction, then its projection is minus F. If F is orthogonal projection to the direction, then it is 0. Projection F along x-axis and along y-axis. Projection of F along x-axis Fx, along y-axis Fy. To find Fx and Fy, cosine alpha is equal to adjacent over hypotenuse. Adjacent is Fx, hypotenuse F. So cosine alpha equal Fx over F. Then Fx equal F cosine alpha. Now, to find sine alpha is equal to opposite over hypotenuse. Opposite is Fy, hypotenuse F, then sine alpha equal Fy over F. Then Fy equal F sine alpha. Newton's first law, principle of inertia. Under the action of many forces whose resultant is 0, keeps moving in uniform rectilinear motion. If it was initially in motion, summation of forces equals 0. Newton's second law. If an object of mass m is under the action of many forces whose resultant force is not zero. It moves with an acceleration a of same line of action and direction as f. So Newton's second law is summation of forces equal ma. Exercise 1. F equal 3 Newton friction force. F equal 10 Newton force. M equal 3 kilogram. Calculate the acceleration of object A. First, apply Newton's second law. Apply Newton's second law. Summation of forces equal ma. The forces acting on A are reaction, weight, friction, and traction force F equal ma. Projection these forces along positive direction. That's positive direction. Then R, projection of R is 0. Projection of W is 0. Projection of F minus F. Projection of traction is F equal ma. So F minus F equal ma. Then we can say that A equal F minus F over m equal 10 minus 3 over 3 equals 7 over 3 meter per second square. Summary for all. Newton's first law: the motion of an object does not change unless it acted on by a net force. Summation of forces equal 0. Newton's second law: summation of forces equal A. Newton's third law: it is principle of interaction. Fa on B equal minus Fb on A. Question 1. The time equation of rectilinear is given by x equal 8t squared plus 5t minus 4. Number 1. What's the type of motion? Justify your answer. The type of motion is uniform accelerated rectilinear motion, since its equation in form of x equal 1 over 2 8t squared plus v0t plus x0. Number 2. What is the initial speed, initial position, and acceleration? Initial speed v0 equal. Compare half a is equal to 8. v0t is equal to 5t. x0 is equal to minus 4. So v0 is equal to 5 meter per second. x0 equal minus 4 meter. Half a equal 8. So a equal 8 times 2 equals 16 meter per second square. Number 3. Find the position of the object at t equals 0. At t equals 0, x equal 8 times 0 square 5. 0 minus 4 equal 0 plus 0 minus 4 equal minus 4 meter. So x equal minus 4 meter. 4. Find the position of the particle at time t equal 5 seconds. At t equal 5 seconds, so x equal 8 5 square plus 5 times 5 minus 4 equal 200 plus 25 minus 4 equal 221 meter. So x equal 221 meter. Number 5. Write the time equation of the speed what would be its speed at t equals 3 minutes? First, at time equation of speed, we know that v equal at plus v0. So v equal a is equal to 16t, v0 is equal to 5 meter per second. At t equal 3 minutes, so it is 3 times 60, 180 seconds. At t equal 180 seconds, then v equal 16 t plus 5 equal 16, 180 plus 5 equal 2885 meter per second. Now question 2. A bag of mass 0.5 kilogram moved on a horizontal air table under the action of tension force T and submitted a friction force in opposite direction of magnitude F equal to Newton and gives the following registration: M0, M1, M2, M3, M4, and M5. First, the distance between M0 and M1 is 10 centimeter, M1, M2, 20, M2, M3, 30, M3, M4, 40, M4, M5, 50 centimeter, and the tau is equal to 0.1 second. Calculate the speed V1. V1 equal V02. V02 is M0, M2 over T2 minus T0 equal M0, M2 is equal to 10. M0, M2 is equal to 10 plus 20, 30 centimeter over 2 tau. Tau is 0.1. 30 centimeter is 30 times 10 power minus 2 over 0.2 gives 1.5 meter per second. V2 is equal V1 is 3 equal M1 M3 over T3 minus T1 equal M1 M3 is equal to 20 plus 30 50 centimeter over 2 times 0.1 equal 50 times 10 power minus 2 over 0.2, 2.5 meter per second. V3 equal V24 equal M2 M4 over T4 minus T2 equal M2 M4, the distance is M2 M4 is 30 plus 40 70 centimeter times 10 power minus 2 over 0.2 equal 3.5 meter per second. And last, V4 equal V35 equal M3 M5 over T5 minus T3 equal M3 M5, the distance between M3 and M5 is 50 plus 40 90 times 10 power minus 2 over 0.2 equal 4.5 meter per second. B. Calculate the acceleration of motion A2 and A3 at M2 and M3. A2 equal A1 3 equal V3 minus V1 over T3 minus T1 equal V3 3.5 minus V1 1.5 over T3 minus T1 2 tau equal 2 over 2 times 0.1 equal 10 meter per second square. A3 equal A2 4 equal V4 minus V2 over T4 minus T2 equal 4.5 minus 2.5 over 2 tau equal 10 meter per second square. Part C. What's the nature of motion y? A2 equal A3 equal 10 meter per second square equal constant. Then the motion is uniform accelerated rectilinear motion. D. Write the time equation of this motion by taking v0, 0 and x0 equals 0. The motion is uniform accelerated rectilinear motion. Then x equal half at square plus v0t plus x0. v0 is 0, x0 equals 0, then x equal half, a is equal to 10 t square, x equal 5t square in meter. Part E. Calculate the resultant forces acting on the puck. Resultant forces equal ma. So F equal ma equal is equal to 0.5 times acceleration 10 equal 5 Newton. F. Deduce the magnitude of tension force. Summation of forces equal N plus W plus T plus F. Projection along positive direction. So summation of forces equal 0 plus 0 plus T minus F. So summation of forces equal to 5 equal T minus F is equal to, then T minus 2 equal 5. So T equal 5 plus 2 equals 7 Newton. Find the resultant force of the following figure. F1 equal 1 Newton, F2 1 Newton, F3 1 Newton. The angle between F1 and F2 is 60 degree, and F2 F3 is 60 degree. First, F1 2 square equal F1 square F2 square 2F1 F2 cosine alpha equal F1 1 square F2 1 square plus 2 F1 F2 cosine alpha is cosine 60. The angle is 60. The resultant between F1 and F2 is F1 2 here equal 1 plus 1 plus 2 times 1 over 2 equal 1 plus 1 plus 1 equals 3. Then F12 equal radical 3 Newton. Now the angle between F12 and F3 90 degree. Angle between F12 and F3 is equal 30 plus 60 equal 90 degree. So F equal F12 plus F3 square equal radical F12 is radical 3 square, F3 1 square equal 3 plus 1 equal radical 4. Radical 4 is equal 2 Newton. Question 4. Majd pulls a box A of mass 800 gram along a rough horizontal track by exerting force of 10 Newton. The acceleration of block is 2 meter per second square. Name and represent the external forces acting on the block. Reaction, weight, force, traction force, and friction. Reaction force, F traction force, W weight, and friction force. B. Apply Newton's second law to determine the magnitude of the friction force exerted by the block on A. Apply Newton's second law. Summation of forces equal MA. The forces are reaction, weight, traction force plus F friction equal MA. Projection along positive direction. 0 plus 0 F minus F equal MA. 10 minus F equal 0.8 times 2. 10 minus F equal 1.6. So 10 minus F equal 1.6, then minus F equal 1.6 minus 10 equal minus 8.4. So F equal 8.4 Newton.